And welcome YouTube to the Daily Space Weather. The most prominent feature here at the Smash News Network, least busted name in news. I'm your host Dan, aka Smash-A-Mash, and the first thing we're looking at here is Magneto hydrodynamic pressure from Earth's magnetic moment from space. So out to about 12 Earth diameters, this is the Magneto hydrodynamic pressure you can expect based on the modeling of the space weather modeling framework. If you want to read more about that, head to the Geospace Magnetosphere Movies page and click on details. There are a lot of variables that are used to create these models. We're seeing a fairly homogeneous pressure here at the moment. Still having a slightly elevated solar wind. We'll get to that in a moment. First, ground magnetic perturbations. Geospace Delta B, Earth's magnetic moment from the ground. So like the last video, this is 4 hours. This is 4 hours of the Geospace Delta B changes to Earth's B field. And we do have a little bit of an elevated solar wind speed. We did just get a NOAA alert just before recording the video that we may go into geomagnetic unrest conditions. I'm not sure the basis for that. I don't see any data to back it up, but we'll see what happens. There's your ground magnetic perturbations, Earth's magnetic moment from the ground. KP index is a measurement of global geomagnetism. If you want to read more about that, click on the Details tab. Current conditions are geomagnetic calm. It's a KP3. KP3 is the current situation for the planetary K index. Next, looking at the real-time solar wind, it's fairly unremarkable here over the past 24 hours. Current conditions are about 460 kilometers per second for the velocity, solar wind density just over 6 protons per cubic centimeter. Maybe NOAA was seeing this shift in the BZ, I'm not exactly sure. We don't see a super strong field or anything. I don't see any reason to expect geomagnetic unrest at the moment. We do see the subsiding of a proton event, and we've seen a few over the past week. Current conditions are calming down as far as the proton flux. Relativistic particles finally subsiding there around the Earth's polar regions in Earth's field-aligned currents. Next, the GOES magnetometer. Some spiky readings here. And we may not end up in a North Pole-oriented current sheet after all, folks. And we say it all the time, the magnetic environment can change with basically no warning. Anyway, that's 3 days of GOES magnetometer readings. And let's look at the heliospheric current sheet. So the plasma that comes out of the sun is oriented to one pole or the other. And we were expecting a North Pole current sheet to show up here. Instead, we're expecting a sunspot to rise in the northern hemisphere. We'll get to it. Before we do that, here's the line of sight ecliptic plane field plot. We're expecting an active region rising here in the northeast to indeed be a sunspot. Just to reiterate, the magnetic environment can change with basically no warning. This data was already about an hour and 44 minutes old when we recorded this video. So this is a YouTube exclusive. We did not stream this one live. We did make a space weather video earlier than this, which we streamed to Twitch. Next, moving into coronal holes. Here's your line of sight coronal hole plot. It also shows you the sun's B field in blue. South Pole oriented coronal holes as they migrate to the north in red. North Pole coronal holes shown in green as they migrate to the south. It's sort of the main feature of a solar cycle, the magnetic field progression and reversal. It's not just sunspots, it's a little more complex. And here's a visual, 193 angstroms. You can see some coronal holes over here in the east. Again, I think this active region rising up here is going to be a sunspot. We will endeavor to keep you posted on that. Next, we'll move into sunspots. We're seeing the setting of sunspot 2975 and the associated regions around it. It's still capable of producing major flares. The likelihood of large flares is still quite high, mainly as a result of sunspot 2978 and 2981. I think we're going to have a sunspot up here. It'll be sunspot 2986, assuming nothing happens in the meantime. And again, don't assume nothing will happen in the meantime. The magnetic environment can suddenly change. Likelihood of solar flare still quite high. 2975 and the associated regions can still produce significant solar flares. So here's our 1700 angstroms wavelength from the SDO. It's great at showing the darkened umbral regions of sunspots. By the way, don't forget to visit our links. Support the channel via our homepage, smashomash.com. We're also on BitChute. Look at the views on BitChute. Over 1,000 views a day. We were at more like 2,000 views a day just a couple of days ago. BitChute.com/smashomash, putting up exclusive content there on the regs most days, featuring exclusive content there. Also regularly streaming to Twitch. Thanks to our followers. If you're a larger Twitch channel, please consider hosting our videos, as I don't think anybody else is doing anything close to what we're doing on Twitch. Here's our homepage. Welcome to the DR Renaissance. Smashomash.com. Click on the link to join the Smash team, and you may see our videos posted there. We've gotten complaints on YouTube about videos not showing up in notifications, so we post them all on the Smash Team page. So if you just click Posts, you click on Smash Team, and then you click on Posts, right there, that link, you don't even have to be logged in to see our publicly visible videos. Next, moving into solar flaring. And thanks to everybody who's become a member of the Smash Team, there are email pushes and all kinds of reasons, incentives, to join the Smash Team. Here's the GOES X-ray flux over the past 3 days. We're seeing kind of a high level here. Sort of an ongoing mid-level C-class X-ray output. Not really what you would call a flare. A flare would be more like a spike. And only C-class intensifications over the past 24 hours. The main culprit of solar flaring in solar cycle 25 has been sunspot 2975 and the associated regions around it. We can say goodbye to it now, as by the end of the day today, it will mostly be hidden behind the northwestern limb, although it will still be capable of sending significant solar flares and possibly even relativistic particles right here to Earth. Just a spectacular sunspot. We may see it rise again in about 3 weeks. Next, we'll show you a diagram of the solar system. We like people to be oriented. It's called astrography. Keep in mind this is not to scale. Planets are nowhere near that close to each other. They're really far away from each other. Remember, folks, if you're at Jupiter, Saturn looks like a tiny point of light. And if you're at Venus, Jupiter looks like a tiny point of light, and if you're at Mercury, Venus looks like a tiny point of light. These things are very far apart. So here's our 1 week forecast for the solar system. Here's where things will be on 4/11. We'll have a gibbous waxing moon, and here's a star chart. If you're up before dawn, you may see Saturn and Mars nearly overlapping there, a little bit south of the ecliptic, Venus a little bit north of the ecliptic, and then Jupiter also rising ahead of the sun. We greatly enjoy this star chart system here. This is in-the-sky.org, and this chart is the all-sky chart. Put in your zip code if you want to make a star chart for yourself. Last but not least, we'll show the views from 2 coronagraphs, one at Lagrange point 5, one at Lagrange point 1. Keep in mind, it's not the Discover. The Discover is measuring solar wind components. This is the Soho-Lasco C3 here on the right. From this perspective, for all you new viewers out there, and thanks for tuning in, for all you new viewers out there, from the perspective of Lagrange point 1, which is where the Soho-Lasco C3 is located, Earth would be behind you. And from the perspective of stereo A, located here at Lagrange point 5, Earth would be off to your right. So here Earth would be behind you, and here Earth would be to your right. We do have a little bit of ejecta headed Earth's way here. It's not what you'd call a significant coronal mass ejection. It's just sort of a stealth coronal mass ejection. And we're not a stealth channel, so press the share button. Tell your friends and foes about us. Thanks for tuning in to The Daily Space Weather, the main feature of the Smash News Network, least busted name in news. We saw a niche in the realm of space weather, and so we decided to not complain about it and just create the content ourselves instead. May that solar wind be at your back. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off.